Alright, so we're talking about solving absolute value inequalities. The absolute value of an expression must be greater than or equal to 0, which we learned when we did just regular absolute value equations, right? So, the steps for solving these, I've actually written them out for you, okay? First, if necessary, you need to isolate the absolute value. That just means get the absolute value by itself. There should be nothing on the outside, right? Then you're going to set up your two problems. You've got one problem that just kind of looks like it is. The other problem, you're going to have the same left side, but then you're going to flip your inequality symbol and then take the negative value of the right side. So really, it's the same as doing the other absolute values, except now you have an inequality symbol, you got to flip it, okay? Then you'll solve for your variable, and then you will graph, alright? So, this is all this is stating. If I have an absolute value that is less than a number, then I'm going to have that absolute value, flip it, is greater than the negative side. See how we changed that to a negative C? And the other one would be the absolute value is less than C. You would just take that left-hand side, inside, keep that the same, and then have your number over there. Okay? So number one. The very first thing I'm going to do is make sure that absolute value is the only thing that's over here. Okay, there's nothing else over here. My absolute value is the only thing that's here. So I'm going to set up two problems. The first one is what is in your absolute value sign, and then you keep everything the same. Alright? Then, you set up the other absolute value, which would be the inside, so that stays the same. But you're going to flip this around, and you're going to change this side to a negative. Alright? So, just to reiterate, one of them will be what's in my absolute value, less than or equal to 2. That doesn't change, right? When you do the second one, you keep that x plus 7, flip your symbol, and change the sign of this over here. Alright, something we didn't talk about on the very first screen is to decide whether this is an and or an or. Alright, that's where this little thing also comes in. Notice that in this one it says and, in this one it says or. So if you start off with a less than C, then that's going to be an and. If you start off with a greater than, then that's going to be an or. Okay? So this very first one is a less than or equal to, so this will be an and. So you need to make sure you decide that in the very beginning. Okay? So if you're less than, you're going to be an and. If you're a greater than, then you're going to be an or. Always look at that very first one that they give you. Okay, don't look down here. That'll get you confused because you have a less than and a greater than. Alright, so we're going to solve. I've got positive 7 over here, so I'm going to subtract the 7. So x is less than or equal to negative 5. And I'm going to do the same thing over here. Subtract the 7. X is greater than or equal to negative 9. So when you have an and, remember you can write that as one statement usually, correct? So you're going to take the smaller of those two, which in this case is the negative 9. That goes on the left, and then the bigger one goes on the right, and your variable goes in the middle. So if you're pointing at the 9, you should still be pointing at the 9. If you're pointing at the x on this side with the negative 5, you should still be pointing at the x. And remember, these should be pointing this way every time. So if one of them doesn't, then either there's something wrong up here, or this is a different kind of and statement, okay? So I'm going to go to negative 9 and negative 5, so I'm actually just going to start here at negative 5. I'm going to go to negative 9, and I'm going to put a closed circle because I do have an equal to bar. And then I'm going to go all the way to negative 5, put a closed circle. And then I'll be shading in the middle. So on number 2, the first thing I do is make sure that there's nothing outside the absolute value. Okay? Now, 0, that's okay to be over here. That's not a problem. Okay? If you looked at the stipulations here on the front page, it says that for C is greater than 0, solve the compound inequality, and same thing on this one. So, do we want it to be greater than 0? Can it be equal to 0? I want you to think about the statement. Can an absolute value be less than 0? Can an absolute value be less than 0? What kind of numbers are less than 0? Those would be numbers that are negative. So can your absolute value be equal to a negative? No. So this would be no solution. And you might want to write out here so that you know why you chose that. You can say absolute value cannot be less than 0. Now, what if this would have said greater than? Can an absolute value be greater than 0? Yes, because numbers greater than 0 are like 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So if this, you got to pay attention and you got to give it a little bit of thought. Okay, so when you see a 0, you need to say, okay, I need to think about this for just a second to see if I can even work this problem out. All right, so I have an absolute value less than or equal to 2, that's okay. So I'm going to set up 2 problems. I've got x plus 3 is less than or equal to 2. So exactly what is up here, right? The inside of my absolute value, less than or equal to 2. Now when I am less than or equal to, that means that this is going to be an and. Second equation is going to be the inside of the absolute value, but then you have to flip your sign and change that 2 to a negative 2. Alright? So I'm going to solve for x. I subtract 3. So x is less than or equal to negative 1. And subtract 3. X is greater than or equal to negative 5. Alright, this is an and, so we should be able to write it in one big statement. So I'm going to take the smaller, which would be the negative 5, that goes on the left, and the bigger of the 2 numbers, the negative 1, goes on the right, and then the variable in the middle. So if I'm pointing at the negative 5, I should still be pointing at the negative 5. And if I'm pointing at the x on this side with the negative 1, I should still be pointing at the x. Remember, these always face this direction, so if they're not, you've got something wrong somewhere. So I'm going to go up here and label. I'm going to go to negative 5, close circle because of the equal to bar. I'm going to go to the negative 1, close circle because of the equal to bar, and then I'm going to shade in between them. Alright, so we have some issues here, right, whenever there's a negative on this side, so you have to give this a little thought. Can an absolute value be less than negative 2? Think about numbers that are less than -2. That would be -3, -4, -5. That would be a no. So this is also no solution. And the reason is your absolute value cannot be less than a negative number. Alright, so look at number 5. I've got the absolute value of 10 minus m is greater than or equal to -2. Alright, so let's give that a little bit of thought. Can an absolute value be greater than or equal to -2? What about the equal to part? Does that pose a problem? So the thing is, I'll never be equal to, right? But I can always, the absolute value of something will always be greater than -2. Correct? Because every time I take the absolute value of a number, it always comes out to be positive, right? So therefore, an absolute value will always be greater than -2. The equal to doesn't matter, right? You don't have to come up with something that would make this equal to that. It just has to fit in this stipulation. So since it doesn't matter what number I plug in for m, every single time it's going to be bigger than the -2. So therefore, this would be all real numbers, and then the way you shade that is, you just shade the whole number line, and put your arrows on the end.
What is that?
Alright, so look at number 6. This says that an absolute value is less than -1. So when we have that negative over here, or 0, then you gotta think, right? You have to give it some thought. Will there ever be a time when you take the absolute value of a number and it be less than -1? No. So that's no solution. What if this was greater than? When will the absolute value of a number be greater than -1? The answer to that is all the time, right? So all real numbers. Alright, so here's a couple of problems where we don't have an absolute value by itself, right? So pull that down here so that you have room to work with it before you do anything with it. Alright, so your goal, first off, is to get your absolute value completely by itself. Alright, so all by its lonesome. So how am I going to do that? The first thing I'm going to do is, I have to get rid of the 4 at some point, right? And I have to get rid of the 1. I'm multiplying the 4, so that should come second, right? I'm going to subtract 1 first. So now I have 4 times the absolute value of 2x minus 5 is greater than, because these cancel, 20. Alright? Now, I'm going to go ahead and divide by 4, right? So I have the absolute value of 2x minus 5 is greater than 20 divided by 4, which is 5. Now, since this is greater than, when I make my two problems, that means I'm going to have what statement? And or? Or, right? So I've got the 2x minus 5 is greater than 5. So exactly like it looks, but you got to take the absolute value bars off, right? Or, I do the same thing on the left, the 2x minus 5, but now I have to flip this around and change the sign of this 5, so make that negative 5. Then I solve for x. I'm going to add 5. So I have 2x is greater than 10. Then I divide by my 2. So x is greater than 5. Or, then I do the same thing over here. Add the 5. So I have 2x is less than 0. Now we always freak out when we get a 0 over here, but we're not going to do that because 0 is the number 2. So I'm going to divide by 2. So x is less than 0. So this is an or. We don't make the one statement, correct? We're going to go up here. We've got x is greater than 5. And we also have to graph the 0, right? So 0, 2, 3, 4, 5. X is greater than 5, so open circle on 5, shade to the right. And we have x is less than 0, so open circle, shade to the left. And remember, ors usually go opposite directions, right? Okay, so I have to get my absolute value by itself, and the only thing that's not inside the absolute value on this side is the minus 3. So I'm going to go ahead and add 3. Now I have the absolute value of n plus 2 is greater than or equal to negative 3. Alright, now when we end up with a negative on this side, right, we don't make any assumptions or try to figure anything out until we get this absolute value by itself, okay? Because what if I would have added 7, right? Then we wouldn't even be worried about this because it would be a 1. So I've got a negative 3 over here. When is an absolute value greater than a negative 3? Always. So that means I'm going, this is all real numbers. I don't need to do anything else. And I will shade the whole number line. Please make sure you think about those, because if you don't, you'll be doing a lot more work than what you need to do. So it actually saves you work when you pay attention to those negatives and zeros over here. Alright, number 9. So if I look up here, on the outside of my absolute value, I have a 3 that I'm multiplying, and a minus 7. So I'm going to go ahead and add the 7. Exhibit A, we didn't want to make that assumption yet, did we? Because now I'm not going to have a negative over there. So that gives me 3 times the absolute value of d plus 1 is greater than or equal to 6. Alright, now all I got to do is divide by 3. So I have the absolute value of d plus 1 is greater than or equal to 2. So I've got a positive number over here, that's good. So now I'll set up my 2 problems. I've got the d plus 1 is greater than or equal to 2. Is this an and or an or? It's an or because I have the greater than or equal to, so or. Set up your second problem. D plus 1 is still on the right, but then you have to flip and change this to a negative. So flip, change to a negative. Then you work out both problems. So I have minus 1, so D is greater than or equal to 1. Or, same thing, subtract the 1. D is less than or equal to negative 3. So, I'm going to go up here. I'm less than or equal to negative 3, so close circle on negative 3, shade to the left. Or, I'm greater than or equal to 1, so close circle on 1, shade to the right. Alright, so number 10. The only thing outside my absolute value is this minus 8, so I'm going to go ahead and add the 8. So the absolute value of 6t minus 7 is greater than or equal to 11. So I'm going to look at this and I say, okay, I've got a positive number over here, so I'm good to go. I'm going to set up my two problems. The 6t minus 7 is greater than or equal to 11. Is this an and or an or? Or, because I have the greater than or equal to, right? So, or, then same left side, flip your sign around, change that 11 to a negative 11. Then work both your problems out. So I'm going to add the 7, which gives me 6t is greater than or equal to 18. Then I got to get this 6 away from my t, so I'm going to divide by 6. So t is greater than or equal to 3. Or, same thing over here, add the 7. That gives me 6t is less than or equal to, if I take 7 away from that, that would give me negative 4. Divide by 6. And remember, you can do that by hand, or your calculator will reduce it for you to negative 2 over 3. Now, if you don't know where that is on a number line, just take the 2 and divide it by 3 in your calculator, alright, which is going to give you, like 3 doesn't even go into 2 one whole time, correct? So that would be like a negative 0.67. Alright, so a little over halfway, right? Halfway would be 0.5. So I'm going to go up here. I've got 0. We're not even going to go to a whole negative 1. 1, 2, 3. So greater than or equal to 3. So close circle, shade to be right. But I'm less than or equal to negative 2/3. So if I split this into 3 pieces, right, it would be the second piece down. So close circle, shade to the left. Alright, so if I look at number 11, I'm multiplying by 3, that's all I'm doing. So to get rid of that, I'm going to divide by 3. So the absolute value of 14 minus m is greater than 6. I've got a positive number here. I'm all alone over here with my absolute value, so I'm going to set up my two problems. I've got the 14 minus m is greater than 6. Is this an and or an or? Or, because I have the greater than, right? Or, same thing on the left. Flip your sign, change the sign on your 6. So I'm going to go ahead and subtract the 14. That gives me negative m is greater than negative 8. And then I still have to get rid of this negative right here, so I'm going to divide by negative 1. And what's the rule when you divide by a negative? You got to flip your symbol, so this would be m is less than positive 8. Or, same thing over here, subtract your 14. That gives you negative m is less than negative 20. Still got to divide by the negative. And flip, right? So m is greater than 20. So this is m is less than 8. So I know I'm not to be 8, and I probably don't have enough. We'll count by 2. So let's say that this is 8. So this would be 10, 12, 14, 16, 18, 20. And it's greater than 20, so open circle, shade to the right. Or I'm less than 8, so open circle, shade to the Alright, on number 12, the only thing out here is this negative 4. So I'm going to divide by negative 4. Now, the same rule applies even if I'm trying to get this absolute value by itself. If I divide by a negative, then that means I have to flip my inequality symbol. So I'm going to flip that around. 12 divided by negative 4 is negative 3. And now we have a negative over here. We have to give it some thought, correct? So, when is an absolute value greater than negative 3? Always. So that would be all real numbers, and then we will shade a whole number line. So what if this would have been less than? When is an absolute value less than negative 3? Never. I almost feel like I'm playing always, sometimes, never. Alright. So I'm looking up here on this outside of the absolute value, you're multiplying by 2, and you're also subtracting 13. So we'll go ahead and add our 13 first. That gives us 2 times the absolute value of 3w plus 8 is less than or equal to 8. Now we can get rid of the 2 by dividing. And remember, your whole goal is to get the absolute value by itself. So before you set up 2 problems. You can't do this unless you get them by itself. Alright, that gives me 4. So positive number, I'm good to go. Alright, so I've got absolute value of this less than or equal to 4. I'm going to set up 2 problems. So 3w plus 8 is less than or equal to 4. Is this and or? This is an and because I have less than. And then same thing on the left. 3w plus 8. Flip the symbol. Greater than or equal to. Change the sign. Now all I have to do is solve for w. So I subtract 4. Or 8, sorry. Subtract 8. So 3w is less than or equal to negative 4, then divide by 3, and w is less than or equal to negative 4/3, which as decimal is 3 goes into 4 one time, so negative 1.3333. You have 1 left. Your calculator will give that to you though, if you want it in a decimal. Or if you wanted it in a mixed number, that'd be fine too. I want my answer like this, but this is just for you, okay? So that'd be negative 1 1/3. Alright, same thing over here. Subtract the 8. So 3w is greater than or equal to negative 12. Divide by 3. So w is greater than or equal to negative 4. And don't forget this is an and, right? So when it's an and, then we can write it as one statement. Alright, negative 4 would be smaller, so negative 4, x in the middle, and then negative 4/3. If you're pointing at the negative 4, still be pointing at the negative 4. We're pointing at it, we're using W, but that's fine. It doesn't matter to me what letter you got. So we've got negative 4 and negative 4/3. So negative 4 is going to be a closed circle, right? So you have the equal to bar. Negative 1 1/3, closed circle. And then you're going to shade in the middle. Alright, so number 14, last one. We're going to subtract the 7. So that leaves us with 6 times the absolute value of negative f plus 3 is greater than 0. Then you got to divide by 6. So the absolute value of negative f plus 3 is greater than 0. So this is one we have to think about, yes? Anytime we have a 0 or a negative over here, that's after we get this by itself, right? Don't do it before. So, when is the absolute value of a number greater than 0? All the time, because that would be a positive number. So, shade the whole entire equation.